And visual interfaces, the old light bulb that indicates you've got a circuit that's active or not, displays on-off state of a single item, and they don't use incandescent lamps anymore, largely replaced by LEDs. So, light diodes. And it's a light when forward bias. That's what we know in the test.
What does that mean?
That means the current is flowing forward.
Reverse bias, there's no current flow.
Being a diode, it only passes current in one direction. You hook up the battery the wrong way, and you don't get any light out of your LED flashlight. It is faster than an incandescent lamp. The new LED turn signals on cars, they don't come on gradually. It's on, it's off. So it's much faster. And they have a longer life. So, visual displays. Most common type of amateur equipment is the liquid crystal display. Requires illumination, either ambient light or backlighting. Lighter contrast than an LED and high ambient lighting. So liquid crystal display is made up of layers. You've got white unpolarized light coming in from the left, and then you've got all these layers set up with colored light coming out. Rotates the polarization of light passing through it. Applying voltage across the crystal changes the polarization. And sometimes with a liquid crystal display, you'll notice that if you're wearing polarized sunglasses, you tip your head the wrong way, boy, that display goes away. It is because the light is polarized coming out of this.
So when you're mounting your radio in your car, and if you wear polarized sunglasses, try it out and see if you can still read it while you're sitting in the seat. Because if you put it at the wrong angle, polarized sunglasses, you're going to be doing this stuff or trying to read it.
Okay, ready for some questions? Here we go. What's the approximate forward threshold voltage of a germanium diode?
Bravo. Yes.
Bravo, very good. What's the approximate forward threshold voltage of a silicon junction diode? Charlie, 0.7 volts. That's a big hit if you're on 12 volts, okay? You know, if your car battery is 12.6 volts fully charged, you just drop that thing to 11.9 volts. What are the operating points for a bipolar transistor used as a switch? Saturation and cutoff. Operating points for bipolar transistor used as a switch. Saturation and cutoff. Which of the following describes MOSFET construction? What's MOSFET again?
Metal oxide.
I hear Charlie.
Bravo.
I hear Bravo. It is Bravo.
Oh.
Gate is separated from the channel by a thin insulated layer. Which element of a vacuum tube regulates the flow of electrons between the cathode and the plate? I hear Charlie, I hear Alpha. Alpha, a control grid. Control is the operating word there. So when, it's going to control the electrons between the cathode and the plate. So control grid is
Regulation
That
is
moves
control.
like a dial or like it has movement, right?
The grid itself does
Screen
not have
grid.
movement, but the voltage input to that grid does have movement, and you can control that. That's how
Okay.
you control the actual flow through the grid.
And the screen grid wouldn't do that.
No, the screen
Have that
grid, the
effect
screen
at
grid
all.
is a stationary voltage.
Okay.
So regulation is control.
What's the primary purpose of a screen grid in a vacuum tube?
Output.
What is meant by the term MMIC, not Mickey Mouse?
Bravo.
Monolithic.
Monolithic microwave integrated circuit. Which is the following is the advantage of CMOS integrated circuits compared to TTL integrated circuits? lower power
And
transfer.
that is why we no longer use TTL.
Yeah.
Yeah, I thought you would say that.
So when you get all these components packed closer and closer together, there's less and less distance to travel. They're faster and there's less heat. And heat is power that's being consumed.
What is typical upper frequency limit for low SWR operation of a 50 ohm BNC connector? PL259, the standard connector, is used in ham radio for most stuff. And then there's a smaller one. It's a twist and lock. It's a BNC connector. That BNC connector is better up through higher frequencies. It's got less loss, and it's good right on up to, you know, almost microwave frequencies. So you would guess, the guess is maybe B for 500 megahertz, or even C, 4 gigahertz. And it's C, 4 gigahertz. So how many megahertz is 4 gigahertz?
4 billion?
How many megahertz is 4 gigahertz?
4 million.
Oh, 4,000. Yep. So it'd be 4,000 megahertz. What's an advantage of using a ferrite core toroidal inductor? A ferrite core toroidal inductor. So a toroidal inductor is just a coil. So a ferrite core has got an iron core in it. What's it going to do to that inductor? It's going to increase the inductance. Larger values of inductance. All of these choices are correct. Most of magnetic fields configure the core. Magnetic properties of the core may be optimized. What kind of device is an integrated circuit operational amplifier? Alpha?
Delta.
Any others? What kind of a device is an integrated circuit operational amplifier? That's an analog circuit. How is an LED biased when emitting light? Forward bias. Okay, how does a liquid crystal display compare to an LED display? Alpha. Yes, higher contrast and high ambient light. Which symbol in figure G71 represents a field effect transistor, FET?
Which one said?
Symbol 1. Which symbol in figure G71 represents a Zener diode?
Well, this one you should
Remember the one that looks like a Z? Little. It's number 5. It's right there.
Yeah.
So you've got the little triangle for the diode, and then this Z zigzag that runs across it. And again, which symbol represents the NPN junction? Never points in.
Bravo.
That's because it's not pointing in.
Right. But you can't.
So
Yeah,
where
it
is
is
it?
too.
Which one is it again?
This one right here.
Yeah,
Because that
bravo.
little arrow is pointing out.
Oh, I didn't even
It's
see
never
the
pointed
arrow.
in.
Okay.
Yeah, it's pretty tough to make out. It's difficult for me to see from here. Which symbol represents a tapped inductor? So an inductor is a coil. That's going to be the curly line. And a tapped inductor is going to have a little arrow pointing at one of the coils. Or maybe just a line connecting. And that should be right there. And that's symbol 7. Okay, which of the following describes the function of a two input and the gate?
Bravo.
Bravo is correct. Output is high only when both inputs are high. How many states does a 3-bit binary counter have? We just did this.
Charlie.
Charlie is correct. What is a shift register?
Alpha.
Alpha is correct. Practical circuit, rectifiers and power supplies. Okay, we got rectifier circuits as part of the power supply. We have halfway of rectifier. Only one half of the AC cycle is converted to DC. That creates a series of widely spaced pulses at the frequency of the input voltage.
So you get the full wave, and a half wave is half of it, or 180 degrees of the circle.
And it's
What does
difficult
that
to
mean in
follow.
English?
That was plain.
Yeah, you're talking about rectifier circuits.
So,
I mean,
okay,
because we saw antennas that radiated stuff in degrees, but
now
now
we're
you're talking about
now we're
stuff
talking
flowing
AC
through
to
the-
DC. We're taking AC current
from the
and
wall.
making DC out of it.
Okay.
So AC's going
Why is
like
there-
this.
AC current,
Oh, it's the current of the AC.
yeah,
Right.
Okay.
So the AC got a peak at the top and a peak at the bottom. So it's only taking the voltage for half of the cycle. And if you want all of it, you gotta get another one in there for the other half of the cycle, and you get a full wave.
So the advantage of a half-wave rectifier over full wave is it only requires one diode. So yeah, you've got half of the components in there. That means it's cheaper to produce. And there may be some situations where you don't need a full wave. All of the AC cycle is converted to DC power. Creates a series of close-spaced waveform pulses at twice the frequency of the input voltage. So that makes it a lot easier to smooth out. So if your input frequency is 60 cycles, the output frequency is going to be 120, and those pulses are going to be efficient and smooth, easy to filter out. Uses two diodes and a center tap transformer.
So this is inside of what?
When you get your license, and the first rig you get is probably going to be a 2-meter or a dual band rig. And it would be set up for 12 volts. If you want to use that in the house, you're going to need some kind of a power supply that goes between that transceiver and the incoming 120 volts on the wall. That's what this is. So diodes can be connected in parallel to increase the current capacity only if you put a small value resistor in series with each diode to equalize the currents between each diode. Can you explain why?
If you don't equalize the current, what you're going to do is you're going to exceed the wattage rating of one of those diodes, possibly more than one. So you're going to blow the darn thing up, at which point the whole circuit's going to fail.
Diodes in series. Diodes can be connected in series to increase voltage capacity only if you put a large value resistor in parallel with each diode to equalize the voltage across each diode. Power supply filtering networks. You've got a capacitor, this is an inductor, right there. Is that a transformer?
No.
No. What's this? Is a diode, okay? So we're trying to get current going in one direction.
This guy right here is marginally taking the peaks off and marginally increasing the lower values so that you're getting a little better solid line here than you are here. This guy right here, an inductor by nature, opposes changes in value. It can't help it. It has to do that. By the time you get over here, you've got an almost DC coming out of there. The pulses are down to just very tiny. They're about probably 20% of the original value that they were here, just because of this guy. We're going to even them out a little more so that what we're seeing out here is as close to DC as this circuit can get you. This is not a particularly efficient circuit, but it's a good half-wave starter circuit.
RC or LC network after the rectifier to reduce variations in the DC output voltage. Variations are called ripple. You want to reduce ripple as much as possible. Okay, power supply safety. Fuse an AC input line, on-off switch in the AC input line, and a bleeder resistor. What is a bleeder resistor?
It probably lets
It's
off
one of
some
the
gas.
things that keeps from biting.
Capacitors will bite you, Lord.
It discharges filter capacitors. High value resistor across the output of the power supply. So the main thing that they want you to remember is that you want a bleeder resistor in there to discharge the filter capacitors, so that when you open the thing up after you've had it on, you don't get zapped by the capacitor. Rectifiers and power supplies, switch mode, or switching power supplies. The AC input voltage is rectified and fed to a solid state oscillator. The oscillator generates a series of high frequency pulses, 20 kilohertz or more. Pulses are applied to the primary or transformer. The output of the secondary is filtered and set to the load, and the voltage is regulated by varying the pulses fed to the transformer. Switch mode, switching power supplies. High frequency allows use of smaller components compared to the linear power supply.
One really big point about switch mode power supplies is, first turn them on, they may or may not be stable. I have a radio, ICOM 7300, that if you turn off the power supply and the radio is on, when you turn the power supply back on, the radio comes on, and it burned out the, I don't know, keyboard, whatever it was in the radio, cost me almost $300 to get it fixed. So, be sure if you're using a switch mode power supply that you turn your, whatever equipment is hooked up to it off first. Turn
And
your
that's a-
power supply on and let it stabilize, then you're probably going to be okay.
And that's a good habit to get into regardless of what
Yes.
type of power supply you're using. Turn the power supply on first, count to 3, then turn your equipment on.
Yep.
That's the same in an automobile too. Okay, you got your rig mounted under the dash, and you've got it set so that it's on all the time, and you turn the ignition on and the rig comes on. Well, you get a good spike every time you hit the ignition switch. So the advantages over linear: smaller size, less weight, higher efficiency. Disadvantage over linear power supplies are noise generation. Batteries produce energy by electrochemical reaction, used by amateurs for handheld operation, portable operation, mobile operation, and emergency operation. And batteries come in all shapes and sizes. And this is your primary battery, is the non-rechargeable.
It's a recharge.
No, stop.
Oh, that's nice.
Non-rechargeable examples are carbon zinc, alkaline, silver nickel, lithium, mercury, silver oxide. So secondary batteries are rechargeable batteries. The electrical chemical reaction is reversible. Battery can be recharged. The examples include lead acid, nickel cadmium, nickel metal hydride, and lithium ion. Secondary, the minimum allowable discharge voltage for a maximum life of a standard 12-volt lead acid battery is 10.5 volts. What happens if you drop below that?
Power doesn't start.
Can't recharge.
And so it says, note, 10.5 is for the test. In the real world, do not go below 12 volts on a lead acid battery. 12 volts is 50% and is the lowest you should go. 10.5 volts will reduce the life. It's reducing the life because as that drop, you're starting to sulfate the plates. You're putting a coating on those plates. That sulfation is difficult to remove. You've got to pulse that sulfation off. A standard battery charger won't do that. Some of them do. But say it's in a car and you do that repeatedly and drop it to 10.5 volts, you will kill that battery. So, again, rechargeable batteries. An advantage of batteries with low internal resistance is their high discharge current. That's also an advantage with the lithium ion is lithium ion batteries. Not only can you run them pretty much right out to the end of their useful life, but man, you can really hit them hard. I mean, some of these 100 I've got 100 ampere hour lithium ion that will take 100 amps
I got it.
and just come right back again. Charging, they never attempt to recharge a primary cell battery, like a zinc battery. You can't recharge them, they will blow up. Always use proper chargers. NiCad and nickel metal hydride batteries are charged with a constant current until the voltage rises to a specified value. Yeah, basically they have different charge curves, and you'll want a charger that matches the charge curve of the battery. So they say you cannot put out a lithium battery fire. Lead acid batteries are charged with a constant voltage, not a constant current, but a constant voltage, until the current drops to a specified value.
And lead acid batteries will blow up if they freeze.
Oh yeah. Well, if you freeze and try to charge it.
And try to charge it.
Yeah.
Yes, I know that firsthand. I blew up 2 in my face.
Sure.
Lead acid batteries give up hydrogen gas during charging.
Okay, just on
That's
that.
another problem with having a lead acid, a flooded lead acid battery in the house. I don't want them in the house, especially around electrical equipment where you might have a spark.
So,
You're putting out hydrogen gas as you charge. Just stay away from it.
anything with liquid in it, leave it out of your house.
Yeah.
Even if
Now,
it's
you can
all
use-
sealed.
You can have a sealed lead acid, that's your absorbed glass mat or your gel cell batteries. Those are fine in the house, and you can tip them on the side, you can stamp on end, they don't care.
So the absorbed glass mat, you turn it upside down and it's flat. Same with the gel. They're sealed and they don't have liquid hydrochloric acid or sulfuric acid. They're safe to be in those environments. You can have them under your bed.
So alternative power, generators. So you've got a portable generator on the left, a sort of portable generator on the middle, and a stationary generator on the right. So you can have gasoline powered, diesel powered, or propane fuel. Some are dual fuel, they'll do gasoline and propane. That's probably the best solution. The big one on the right, very often they connect those to a natural gas line coming in the house. So less than a kilowatt to over 10 kilowatts. What do you need to run a house? Well, it depends. Depends on what you want to run. So I've got a big inverter that I put in the back of my Chevy Volt. I plug that into the house. And I've got a maximum of about 2 kilowatts that I can run off of that at 220 volts. I can run pretty much anything in the house, but I can't run them all at the same time. I'm not going to run my heat pump, my refrigerator, and the dryer. I'm not going to do that. I'm not going to run the dryer at all. But the heat pump and the refrigerator, yeah, I can run those. Do I turn all the lights on at the same time? No, I'm going to juggle on loads. So what do you need? You could probably get away with 2 kilowatts, 3 kilowatts, and run the whole house. If sufficient light falls at a p-n junction, free electrons of the n-type material will absorb energy and flow across the junction into the p-type material. Voila, you have a solar panel. Most common material is silicon. Most efficient material is gallium arsenide. A fully illuminated silicon photovoltaic cell yields an open circuit voltage of 0.5 volt. And they string a bunch of them together in a string until they get whatever they need. Usually it's something well over 12 volts. They want 18, 20, 26 volts. Rapidly improving in commercial viability for power generation. And wind power. There are small wind power generators. The best solution if you're off-grid is a combination of solar and wind.
It's right here.
And then you need some way to store it. So we need to store it during periods of daytime, and when the wind is blowing, save it up at nighttime, and when the wind is calm. A solar system must have a diode, remember we talked about that, in series with the solar panel and the batteries, to prevent discharging the batteries back through the solar panel during low light conditions. The individual cells in the solar panel are connected in a series parallel configuration. When connecting a solar panel to a lithium ion phosphate battery, a charge controller must be used between them. That's true with any battery.
Yes,
Not
always
to
use a charge controller regardless of what battery you use.
Right. Why? Because the solar panel is running at 18 plus volts. You can cook that battery. If you're using just a flooded lead acid, you'll boil the heck out of that electrolyte. No, you want some way to limit how much charge you're giving the battery.